having a look at the graph capabilities of ColourSpace, specifically looking at the 3D volumetric graphs, as they really are the unique benefit of using ColourSpace, but we'll be looking at all of the different 1D and 2D graphs as well. The graphs themselves are held within the profiling window, where you have access to the X, Y, UV, the 3D volumetric graphs, EOTF, differential EOTF, separation, balance, etc., etc. At the moment we're not seeing anything in the way of data because there is no profile data as yet recorded into this window. We are targeting Rec 709. At the minute the target gamut is linked to the EOTF. It will be separated, isn't yet. Obviously you've then got the subspace capabilities as well. You can see that as well we are targeting the standard 100 nits for SDR colour spaces, as well as the minimum of 0, which gives us an infinite contrast ratio. If we close this and actually look at a profile, we'll get a little bit more data to play with, and we've got in our library our existing profiles, and we'll pick on Convision. There we go. It's got a profile with drift data, so we can have a look at everything. And if we open that up, at the moment we are looking at a specific set of data, so that means that I've left in my graph options. In this case you can see that I'm just looking at the orange data points, so we turn those off. We're now looking at everything in the graph relative to Rec 709 and relative to a maximum 100 and a minimum 100 nits. So we can see that the orange points are between a delta E of 1 and 2.3, and red is 2.3 and above, and green is below 1. Now at the moment, as I say, we're looking at the default min and max. If we use the little up arrow, it will now swap the values over, so that we're now looking at the actual measured min and max. It gives us a bit more of a feel for what the display is actually capable of. You can see now we've got some green points pop in. But we are still looking at it relative to Rec 709, which obviously we will want to do once we've calibrated it, but this is an uncalibrated display, which we're just using for an example. And you can see that the outer light grey line is the actual display's gamut, and the white line is the target gamut. If we go in and turn off others, so we're just looking at the grayscale primary and secondary, then you can see now the measured gamut versus the target gamut. We can even turn on our tangents and see where the points are relative to where they should be, the measured points that is. So look at the grayscale, for example. You can see the target is at the end of the tangent line, and the actual measured points are obviously all shown at the end of that line. Okay, let's put the others back on. Now, as I say, while that's useful, in this instance what we'd like to do is actually assess the display relative to itself, so we can get a feel for what it really is capable of doing. I mean, obviously at the moment we can see that it's never going to make blue because it doesn't have a blue primary that is in alignment with the blue of Rec 709, and that is defined slightly more visibly in, oops, wrong one, in the RGB cube. You can see that here is our target blue. You can see that our actual blue is a long way off, increasing from black. And okay, it's exaggerated because we're looking at it in linear light space rather than the logarithmic light that our eyes actually work to. So it does actually enhance the error, as it were, but very helpful nonetheless. Okay, but looking at it relative to what it can do, if we go back into our library, back into our profile, we'll modify Convision Raw. We will call it EXTR. We will extract the space, and that will now be in our, there it is. So we can now use that as a target colour space. So if we go into settings, and we can now select from our color spaces. There we go. And we're now comparing the actual raw profile of the display with its own maximum gamut and an average gamma. At the moment, again, it's dropped back to targeting the default 100 nits and 0 nits min and max for an SDR color space, but we will just use the up arrow to replace that with the measured data. And we now start to get a better feel for what the display can actually do. Again, using, for example, here the RGB cube. Let's look at the XY, and you can see now where there is more of a volumetric error within the display. If you can see a little cross in there as well, let's zoom into that. That cross is the selected point in the profile, so it enables us to select a point, in this case it's one of the grayscales, and actually zoom into that. So if we say select a different one, let's select just something on the edge so you can see it, a bit of green for example, pops up all the data there. We can actually look at either the selected point and the area or the area around it, or just the point, all the displayed points in the graph as defined by the boxes here, selection boxes, or we can override those and say show everything, so we can see all of the points that exist in the graph, whatever they may be. Let's just tick those back on, close that. But if I go back to the 3D one, now you can see that the point has moved there to on the edge of the 3D graph as we selected. Okay, looking at the graphs in the window here, these are all obviously resizable and the same within the actual volume of the graph itself as well. Let's put that back to its small size, because one of the useful things with ColourSpace is that we can now pop out alternate graphs. So if I control click on the CIE, it will pop out a selection of graphs. Let's just move that out of the way. That I've used previously. So here we've got a zoom in on the red, green, blue and the grayscale. We can have a gamma graph, a differential version of the gamma, and we'll call up the RGB balance. And again, all these graphs are independent but showing obviously the same data at the profile we're working on. And if we were doing live measurements, these would all update with each measurement so that you can see exactly what's going on when you're doing a manual calibration, or as in this case when we're doing an assessment of an existing profile. As I said, all of the points are color coded, so if we look at, actually let's do it the other way around, look at green, you can see that these are all the points in the profile that have a delta of less than 1. So you get a feel for where the accuracy in the profile is, and then we can say, okay, look at the ones that are between 1 and 2.3, and then look at everything that is above 2.3. So each of the graphs gives you a feel for where the display has a greater level of accuracy versus a greater level of error. You can add to that with the tangent lines, which show you where the point actually is, and the end of the tangent line is where it should be. So it gives you a very visual representation of an error in any given area. We can invert that as well and say targets only. So this time it's showing you the actual point of where the measurement should be, and obviously now at this end is where it actually is. But the point also gives you the color, so you can see that most of these errors are in the dark points because they have basically no real color to them until we get into the grayscale. Okay, each of these graphs remembers not just the position but the zoom that you may have applied to it. So if we, for example, go into the OTF and say zoom into that, if I close that graph and then do a control click back on it, it will pop back in the last position and size that we set it to. Double click, right click, resets it. We've also got the ability to use the manual measure window to see additional data, both with the widgets for the zoom of the error and the bar widget, and any point that we select will be represented here. So at the minute we've got the 3 boxes ticked. So although this is showing green, the colour here is a grayscale because they are locked. So it's showing me the nearest grayscale colour to the value selected. But if I now just move the sliders so it defaults back to grayscale, you'll see that when we hit a point that we actually have, these graphs will pick up that data. There you go. So you can see information on that given point, and the point itself is highlighted in the graphs as well. So over here in the zoomed grayscale, obviously in the CIE, the same within the 3D graphs, that cross we were talking about will show you the actual point we're looking at, again based on what we've got selected here. So let's go back to our standard, and then if we unselect the locks, then as we move through any colours, if we hit a colour that we actually have again in the graph, then it all adds the data into the display. Right, I think that pretty much covers, an example of what we've got with the graphs within ColourSpace. Now, obviously, you can make these any size you want at any time to be able to really access the information contained within them. A double click defaults them back to their standard relative size within the window. We will be making some changes so that we won't have to have the bar along the top. And they will be made to follow a little bit more of a fixed grid on the screen, just to assist in being able to position and lay them out, so that you can build up different workflows, and those workflows will be accessible from within the main ColourSpace window, the profiling window. We haven't yet got that implemented, but it will be there. To get a feel of the way the graphs will work, it's actually going to be based on the patch window, so you can see the way that this actually locks to different points and has no borders and no bar, and then the size and position and close capabilities pop up within the graph itself. Hopefully that gives you an idea of what the graphs are like at the moment. Obviously, as with everything that we do, this is a continual work in progress, and there will be a lot more changes coming as we progress further with the capabilities of ColourSpace.